All right, so for each of these, we need to just remember the type of operation that we do and how we go about it. The first one, it's addition. Adding and subtracting are going to work basically the same way. Anytime we add or subtract, what do we need at the very start? Common denominator, absolutely. So in the case of this first one, I got a 6 and a 4. Now, there's a couple different options that people will sometimes use with these. Some people will use 24 by just multiplying them together. That works. But 12 is even better because it's going to save you from having to reduce so much at the end. Because you notice I can make both 6 and 4 into a 12. So I'm going to do that. Now, in order to make them both into 12s, I got to multiply the top and bottom of the first by 2. Whatever we multiply the bottom by to make it into that 12, I multiply the top by the same thing. So for the second one then, I'm going to multiply top and bottom by 3, because 4 times 3 is going to give me the 12. So now I rewrite what I have. Notice both of those are going to be over 12. And then I'm just multiplying the tops to see what the tops give us. Then we can do the addition. Now when we do the addition, the bottom, the denominator, is going to stay the same. Anytime in math something has to be the same in order to do something, that's because it's going to stay the same. So if you have to have a common denominator, it's because it's going to stay the same number. So that stays at 12, and then I do the 10 plus 9 on top, which gives me 19. Yes, you could turn it into a mixed number, but I'm just going to go ahead and call it good there. I'm not going to worry about the mixed number skill because that's not going to come into what we're going to be doing next with these skills. So we're just going to focus on how we do these operations. All right, for the second one here, we're doing subtraction. Subtraction works the same way as addition because, of course, subtraction is just adding a negative. So really the process is the same. I start with getting a common denominator. And of course these are the same numbers, so it's going to look the same, just with a minus in there instead of a plus. And then I go ahead and do the subtraction. Let's see here, 10 minus 9, that's going to give me 1. And remember, I had to have a common denominator, so it stays the same. So it ends up being 1/12 as the final answer. So adding and subtracting, you have to remember that special rule. You got to remember, get a common denominator. Those are the only two that require a common denominator. Multiplication and division, you don't need it. Multiplication of all the different fraction operations is the one that works like you think it should if you're just guessing how to do fractions. You multiply straight across the top, and you multiply straight across the bottom. So on the top, I'm going to do 5 times 3, which gives me 15. On the bottom, I do 6 times 4, which gives me 24. But I'm not done. Because you notice this one can actually reduce. And if we can reduce, we need to reduce. So what can I divide both 15 and 24 by? 3. So we do that. So 15 divided by 3 is 5. 24 divided by 3 is 8. Final answer is 5/8. And then finally, we have division here with this last one. In order to divide, the rule is, in technical terms, it's that we multiply by the reciprocal. In other words, you flip the second fraction and you change it to multiplication. So some people then when they do division, they do look at it as cross multiplying because it is very similar because we're kind of multiplying something that used to be diagonal. But I'll never talk about it in terms of cross multiplying because we'll forget which one goes on top and which one goes on bottom. The actual cross multiplying type of thing, I can't use it with division. I use that when the two fractions are equal to each other. So that's a proportion. In other words, if you got a fraction equals a fraction, then cross multiply. That's the only case. All right, now that we got to this point, we can go ahead and do that multiplication. 5 times 4 is 20. 6 times 3 is 18. Reduce it. I can divide top and bottom by 2. So final answer ends up being 10/9, and we are done. Now, if you got those 4 down, then really you already know everything you need to know and just need to trust your skills now in order to do these 4. So please write down and do each of these 4 problems. Even though there's an X in each one, the methods are still the same. The process is still the same. Just now you got to deal with the fact that there's an X instead of just numbers. All right, so for that first problem, for doing the addition, I still am going to need the same thing I always need at the start of an addition problem, which is a common denominator. So Notice I'm starting with 6 and 4 as my denominators again, so I can go ahead and make my denominator 12. So I know I'm going to end up with something over 12 plus something over 12. And just like before, whatever I multiply the bottom by to get that, I have to multiply the top by the same thing. And so in this case, I'm going to be multiplying the x by 3. So 2 times 5 on the left one gives me 10, and x times 3 gives me 3x. Now I can go ahead and do that addition just like I did before. Just in this case, when I do that addition, I'm doing 10 plus 3x. Well, they're not like terms, so I cannot actually combine them through addition. So the best I can make it is 10 plus 3x over 12. That's as good as that one gets. Now for the second one, for doing the subtraction, we again need to start the same way. We need to get a common denominator. But 12 will not help us as a common denominator in this case. I have one that's a 6 and one that's an x. The only way I can get a common denominator in that sort of situation is by actually multiplying them by each other. So that means I'm going to make both denominators 6x. And then in order to know what that's doing to it, we then go back and we say, okay, so what am I multiplying the top and bottom of each one by to get that? So for the first fraction, 6 times what is 6x? It's got to be times x. So I'm multiplying the top and bottom of that one by x, which means it's going to be 5x over 6x. For the second one, I'm multiplying the x by 6. So that means I got to multiply the top by 6 as well. So 3 times 6 gives me 18. And then we do the subtraction. Now, remember, when doing addition or subtraction, we need a common denominator because that denominator stays the same. So we know it's going to be over 6x. And then on the top, I go ahead and do the subtraction. So 5x minus 18, well, that's going to be 5x minus 18 because, again, they are not like terms. So that is our final answer and as good as it gets. Now, a little detail-y question here. Can we reduce these? For instance, you might be looking at this saying, well, I got an x in both top and bottom there. Can I reduce those? Or I can divide both of those by 6. Can I do that? And the answer in both those cases is actually no. Because there's actually 3 terms here that we have to account for. There's 2 in the top and 1 on the bottom in this case. If I'm going to reduce, I have to divide everything on the top and the bottom by the same. So if I look at 5x, 18, and 6x, there's nothing that goes into all 3 of them. So that's why this is our final answer and as good as it gets. All right, for the third problem here, we're multiplying, and our process hasn't changed. So for multiplying fractions, I'm still going to multiply across the top and multiply across the bottom. So in this case then, 5 times 3 on the top, that gives me 15. Let's stick with the same colors here. 15 over, and then I do x times 4. Well, x times 4 is 4x. Yes, I can multiply the number and the x. I can't add them, but I can multiply them, which is what we're doing in this case. So then, does that reduce? No, there's nothing I can divide 15 and 4 by, so that one is the final answer. And then finally, for the division, always show the step where we flip the fraction and change it to multiplication. Remember, this is called multiplying by the reciprocal. Reciprocal means it's the flipped version of the fraction. We always flip the second fraction no matter what. It's never the first fraction. And the flipping and the changing to multiplication is all one step. It's not 2 separate steps. All right, now we can go ahead and do that multiplication. So x times 4 on the top gives me 4x. 6 times 3 on the bottom gives me 18. Does that reduce? Yes, actually. Because 4 and 18, there is something I can divide both of those by. I can divide them by 2. So if I divide top and bottom by 2, I get 2x on the top, and I get a 9 on the bottom. That then is our final answer. All right, so this is a nice little warm-up and refresher here going into our new unit, which is going to be all about fractions that involve variables, basically. And so we're going to be stepping things up a little bit. These were kind of the simple starting examples because it was just a plain old x. But we're going to be getting into more stuff that looks like this and even doing operations on these. Now, we want to start with just saying how the simplifying process does work when we have multiple terms like this. So go ahead and write down that first one. and then we're going to see how we would actually go about simplifying, or in this case, reducing that fraction. So in order to reduce it, I need to look and see what can I divide all three terms by. So in this case, that's 24, 12, and 16. Yes, there is something I can divide them all by. What is the biggest number I can divide all three of those by?
4.
Yeah, good. It is 4. So I'm going to divide now all of those by 4. So 24 divided by 4 is 6. 12x divided by 4, 3x. The minus stays a minus. And then 16 divided by 4 is 4. Now, before I call that done, I do want to just double check here and make sure. Is there anything else that I can divide 6, 3x, and 4 all by? No. There's nothing I can divide all three of those by. So that means I did, in fact, reduce it completely, so that one's done. With that in mind, reduce that second one. All right, now for this last one here, again, we're looking to see what can I divide all three terms by.
5.
In this case, yes, it's 5. So I'm going to divide all three of those by 5. So 15x divided by 5 gives me 3x. 30 divided by 5 gives me 6. And the 20 divided by 5 gives me 4. So it's 3x minus 6 all over 4. So from there, well, you probably know where we got to go from here. We got to start now doing operations on fractions like those. All right, and we're adding fractions here. Remember that when I introduced x in those earlier problems, we still followed the same rules? That's always going to be the case. So since I'm adding fractions, I still have to start with the same thing I always have to start with when adding, which is a common denominator. The beautiful thing about this problem is we've been started with common denominators. So we already have them both being over 2x minus 9. So that means I can go ahead and do the addition, and I know it's going to be over 2x minus 9. Because the denominator, of course, stays the same. That's the whole point of getting the common denominator. And then we're going to add on the top. Now notice I got 13 plus 4x plus 7. I can't combine the 13 and the 4x. I can only combine the like terms. So the 4x stays a 4x, but I can do the 13 plus 7. So we got 4x plus 20 over 2x minus 9. Now before I call that done, I want to see if I can reduce it. So can I divide, in this case, all 4 terms by the same thing?
No.
No. If it was just those 3 terms, yes. But since there's all 4 of those, no, that's as good as it gets. So this is our final answer for this problem. Have that down, and then we're going to move on to another one here in a moment. All right, next up, we're going to be multiplying fractions that involve these, in this case, a linear binomial. Now, I think this one's a little bit more straightforward. I think you can go ahead and even complete this one entirely on your own. So go ahead and do that multiplication, get the answer, and then we'll check it together here in a moment. All right, so in this problem, we are multiplying. Remember our rule for multiplying is multiply straight across the top, straight across the bottom? So I don't need a common denominator or anything like that. I can go straight into the multiplication. So on the top, 3 times 5, that gives me 15. On the bottom, I need to do x plus 2 times 4. Now, if I'm doing x plus 2 all times 4, that's like distributive property. So I'm going to go ahead and multiply the 4 into both the x and the 2. So that's going to give me 4x plus 8. And then we look to see, can that be reduced at all? 15, 4, 8, no, nothing goes into all of those. So that is then our final answer. This one is done now. All right, now if we can multiply these, then we can divide them. So go ahead and do the division now. And I think you got this handled. Go ahead and do it start to finish, because it still follows all the same rules. Now, since it does follow all the same rules as division did before, the first thing you want to do is you want to rewrite it as multiplying by the reciprocal. So I flipped the second fraction. I changed the division into multiplication. Now it's just a multiplication problem, just like that last problem was. So I multiply straight across the top for 12, multiply straight across the bottom, x times 5 and 2 times 5. We get 12 over 5x plus 10. Then we say, can that reduce And no, it can't, because there's nothing I can divide 12, 5, and 10 all by. Now, the nice part about multiplication and division is that when you know the method on how to do it, they're fairly straightforward and easy, even when we get stuff like this thrown in there with the linear binomials and all that stuff. But now we're going to be doing addition with this. And this can be a little bit trickier just to feel our way through that first step. Write down this problem, and then we'll take a look at how do we complete that first step. So we're doing addition in this case, so you already know what you need at the start, right? Addition means we need to start with a common denominator. Now, here though, I have an x plus 2 and I have a 4. And I want to deal with what we can't do first. Because sometimes we see the 2 and the 4 and we think, oh cool, I can just multiply the first one by 2, because then this 2 here will become a 4. Well, yes, that's true, but it would be 2x plus 4. And this would still just be a 4. They need to be exactly the same. They need to have everything about them being the same in the denominators. So, instead, I'm going to resort to what I can always resort to when needing a common denominator, and that is just multiply them by each other. So I'm going to multiply the first fraction, top and bottom, by 4. And I'm going to multiply the second fraction, top and bottom, by x plus 2. So when we do this work on the first fraction, we get 12 over 4x plus 8. Notice I'm distributing that 4 to both terms. And then plus, now we repeat the same thing with the second fraction. So 5 distributes to x plus 2. That's 5x plus 10. And then the 4 distributes to the x plus 2 again. That's 4x plus 8. It gives us the same thing in the second denominator as it did in the first denominator, which is a good thing because that was the whole point of us doing it, was to get the same denominator. Now that we have the same denominator, now you can go ahead and finish this one out. Do the addition, just like we did that other addition problem earlier. All right, so we now can do the addition. I needed a common denominator because the denominator stays the same. And then we add on the top. Remember, we can only add the like terms. So the 5x stays a 5x, and then I do the 12 plus the 10. There's our final answer. So we're now going to do one last problem. And yes, you do know how to do this one, even though it might look a little intimidating at first. So this problem, when we first see it, can be very intimidating because we have this ugly looking fraction inside of a fraction. So it's like a double ugly fraction. But what does a fraction really mean in terms of operations?
Dividing.
Division, yeah. So the first thing I would suggest you do is just rewrite this as division. And once you've written it in this form, it's just like the other problems that you've done with division. And so we go back to saying, okay, how do we do the division of fractions? Remember, that's multiplying by the reciprocal. So the first thing I do is I flip the second fraction. I change the division to multiplication. And then we can actually do that multiplication. Now, remember, I can multiply 3 by 3x. I couldn't add them, but I can multiply them, which is what we're being asked to do. So the 3 is going to multiply by both of those, and the 12 is going to multiply by both of those. When you do that multiplication, this is what you should be getting, 9x plus 24 over 48x minus 60. All right, and we have one more step here. We need to check and see, can this reduce? Can I divide all 4 of those terms by the same thing? Yeah, by 3. So we do so because we have to reduce if we can. Your final answer should be 3x plus 8 over 16x minus 20.